Hello, welcome to this lecture 3 of Mathematical Foundations of Computer Science. In last section, we have seen about different definitions from set theory. We have studied Cartesian product and different other definitions and concepts from set theory. In today's session, we are going to see about different set operations and set properties, which are very important in solving the problems of set theory. Like discussed before, the in concept of sets as a data structure in Python is motivated from these concepts of set theory in mathematics. So let's see few set operations. Union is an operation where you combine all the elements of both the sets A and B. If there are two sets A and B, it is denoted by A union B. You write it like this: A union B. That contains elements of both the sets A and B. So the roster method or the set builder notation for A union B is A union B equal to X, where X belongs to A or X belongs to B. This is your union operation in set builder notation. So the union of 135 and 123 is 1235, because here 3 is common, but in set we know that common elements are not printed when you print those in using Python programming. So as in mathematics, so we don't repeat the common elements. In the sense, we don't repeat the repeated element. So this is the Venn diagram of A union B. So the complete blue part is your A union B. So all the elements of A and B. So next operation, intersection, same as that. Here we represent as A intersection B. We take the common elements in both the sets A and B. If there are two sets A and B, then we say that A intersection B will include elements which are common in both the sets A and B. So in the set builder notation, X where X belongs to A and X belongs to B. So it means the element which is there in both the sets is included in the intersection. So same example, I have set A 135, set B 123, common elements are 1 and 3. Therefore, it is 1, 3. So this is the Venn diagram, diagrammatical representation of A intersection B. So the shaded part here, this is our A intersection B. So we'll see the next one, disjoint sets. Two sets are called disjoint if their intersection is empty. It means A intersection B is null if there are no elements common. You see 1, 3, 5, 7, 9. 2, 4, 6. This is odd number, this is even number. There is no common element. Therefore, we say A and B are disjoint L sets. Next, principle of inclusion, exclusion. So, this is one very important concept, because we have lot of problems. Maybe during in placements also, or some exams, competitive exams, they ask questions based on this principle of inclusion, exclusion. So, two sets A union B. The property says that n of A union B equal to n of A plus n of B minus n of A intersection B, where this is the elements of only A, this is elements of only B, this is elements which are both. Then you get n of A union B. Similarly, we have the same property for three variables. Like if I ask n of A union B union C, it is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of A intersection C minus n of B intersection C plus n of A intersection B intersection C. This is the property for three variables. There are a lot of problems we see in different competitive exams which are based on principle of inclusion and exclusion. We will also see few problems. So what is the difference between two sets A and B? If it is A minus B, it means elements which are in A but not in B. Elements which are in A but not in B. That is your A minus B. And the difference of A minus B is also the complement of B with respect to A. The difference A minus B is nothing but complement of B with respect to A. Okay. So that is also one definition. So the notation you see, A minus B means X where X belongs to A and X does not belong to B. So the elements which are only in A but not in B comes under difference. So you see, I have two sets 1, 3, 5. and 1, 2, 3. So the difference between both, 1 is here, so I cannot consider. 3 is also there in B, I cannot consider. Only element left in A is 5. So A minus B value is a single element 5. Right? Similarly, if you find out B minus A, so 1 and 1 is common, erase, 3 and 3 is common, erase. The only element left in B is 2. Therefore, B minus A will give me an element 2. Complement. So in Venn diagram, this space is called as universal, which is denoted by U. Universal means all the numbers. If it is a number set, all the numbers. So A forms a small subset of this union. So the complement of set A, denoted by A complement, A bar, is the complement of set A with respect to U. Therefore, the complement of A. See, this is A. Complement means other than A. So the remaining part, this part, the empty space, that is our complement. So it is written as U minus A. So let A be the set of positive integers greater than 10. Then A complement will be 1 to 10. Because we are saying integers and that to positive. So it starts from 1 to infinity. In that I am saying A is a positive set of positive integers greater than 10. Means after 10 everything. So what is its complement? The remaining elements. That is 1 to 10. Symmetric difference is one very important concept. We have the same function in Python programming as well. Symmetric difference, symmetric update, difference update. Like this, we have so many inbuilt Python functions for sets. So what is the symmetric difference? It is represented by A, this symbol, triangle, A triangle B, A delta B we say, A delta B. So it is nothing but A minus B union B minus A. A minus B union B minus A will give you the symmetric difference between two different sets. On this also we have so many problems. And the very important concept is set property. So there are a lot of properties which are useful in solving the problems. So few of them are listed here. Identity loss. You see, A intersection union is A, because when you have a universal set like this space and A is here. So I am asking what is the common part in A and in U. So this is only A is the common part. So like this, A union null is A. A along with empty set is always A. So these are identity loss. Then we have domination loss, A union U, which is the union means completely, the bigger set will come under that. So U. And A intersection null is null. What is common in set A and null is null. Similarly, we have idempotent loss, A union A equal to A intersection A equal to A. When you have same thing, when you do union, it is the same set. Complementation law, we all know this, A complement, its complement is A. Double negation, negation of A and its negation of negation A, it is A. Then commutative loss, so A union B equal to B union A intersection B equal to B intersection A. These are also applicable laws. But see, this is not true for A minus B. A minus B with union operation, commutative property satisfies union operation and intersection as well, but not with other operations like subtraction, because we have seen that A minus B is different from B minus A. Then we have associative loss, very easy loss. A union B union C is equal to A union B union C. Whether you associate AB first or BC first, the result is same. Distributive law, where you have A union B intersection C is equal to A union with B intersection C. So first I will take A union B intersection A union C. A union B intersection A union C. Okay. Similarly, the other one. The very important laws are De Morgan's laws. Very popular in all the concepts of mathematics. We know that this is very popular. It is nothing but A union B whole complement is nothing but you see, you apply complement to A, it becomes A complement. You apply complement to union becomes intersection. You apply complement to B, it becomes B bar. Similarly, if you have A intersection B whole complement, you apply individual complement to A, it becomes A complement. Intersection complement will be union, B complement will be like this. Okay, so A bar union B bar. And then we have other two absorption and complement laws, which are very simple to solve. Let us see a few problems. So, given A equal to A, B, C, D, E and B equal to A, B, C, D, F, G, find out A union B. What is A union B? So, A union B means you have to combine both the elements, combine all the elements of set A and B. So, it will include A, B, C, D, E, F, G, H all together. Okay, so this is combination of all the A intersection B means only common elements. So only common are A, B, C, D, E and A, B, C, D, E. So A, B, C, D, E. A minus B. Elements only in A but not in B. You see A is common. I cannot consider that. B is common. Strike off C common. Strike off D also is common. Strike off E is also common. Nothing. So what is the element left? Nothing. So this is null. Whereas B minus A, common elements if I delete, B is left over with three elements, that is F, G and H. Okay, simple problem based on the two sets. Similarly, if A, B, C are sets, show that A union B intersection C equal to C bar union B bar intersection A bar. Let's try to solve this. So apply De Morgan's law on this. It simply looks like A union B whole bar. So let's apply our formula. It becomes, so apply complement on A. It becomes A complement. Union becomes intersection. Then it becomes B intersection C whole complement. Next, apply De Morgan's law again to the second part. So it becomes A bar intersection. If you apply here, it becomes B complement union C complement. Next, you apply commutative law on this second part. So this becomes A intersection C bar union B bar. Again apply commutative law of intersection on this. So this is A intersection something here. You interchange it. So this becomes C bar union B bar intersection A bar. So we got the result. This way, using the laws, you have to solve the problems. So given x is a non-negative integer, even integer, and y is, b is x by y, x where y belongs to n and x equal to y plus 1 means integers. So it is from 1, non-negative means 1, 2, 3, so on, infinity. This is our set. So what is A? A is this, 1 to so on. Because x is a non-negative, even integer. So you have to take, your integer set is z is this. So A becomes only even numbers, 2, 4, 6, 8, so on. Then B equal to x where y belongs to n and x equal to 2y plus 1. X equal to 2y plus 1. So y belongs to natural numbers. So I will have from 1. So put y as 1, x equal to 2y plus 1. Put y as 1, 1, x becomes 3. Then put y as 2, x becomes 5. Put y as 3, x becomes 7. So your B set is nothing but odd numbers starting from so on. Starting from 3. Similarly, C, x where y belongs to n and x equal to 4y. X equal to 4y. It means your C set is nothing but you put y as 1, 4, 8, 16 and so on. So this is our C set. Okay. After this, you have to find out A union B. What is A union B? These two common elements. Are there any common elements here? Nothing, because this is all even number, this is all odd number. We will very hard to find a common element. So this is null. Oh, sorry. A union B means here you have to combine all. You have to combine all. So this becomes 2, 3, 4, 5, 6, 7, 8, 9, so on. So numbers starting from 2. Whereas A intersection B is null. What is A complement? A complement is, this is even number set. A complement will be odd number set. A union C, 2, 4, 6, 8, 4, 8, 16. So union means you have to combine everything. So by default, write all the even numbers. So A union C will be A as it is. No change in that. A minus C. So elements in A but not in C. So we have to remove 4, 8, multiples of 4 we have to remove, remaining all. Similarly, B delta C, symmetric difference between B and C. So this way you can solve the problems. So using the identities, prove that this is null. We have to prove that this equation is null. So how we do that? You see here, this is A union B intersection C. This is same as A union B. intersection A complement union B, because you assume maybe if I take here PQRS, that is very easy. So this is, let's take Q equal to B intersection C. So this will look like P union Q intersection P bar union Q. So if you apply reverse distributive law here, reverse distributive law, it means I can write this as P intersection P complement union Q. P intersection P complement union Q. Why? See, this is equal to P union Q. This is equal to P union Q and P intersection Q. That way, reverse distributive law you have to apply here. Let's see how we solve this. So that's what I have done. I have taken this as a set. Now you see, I have subtracted them. This and this combined, it became A union A bar intersection B intersection C. So what is A union A complement? That is U. It is U. U. And U intersection B intersection V will be B intersection C only, because union intersection something will be the remaining part only. So this is B intersection C. Now B intersection C intersection B intersection complement. It is same as A intersection A complement. That will be definitely null, because there will not be any common element between A and A bar. So it becomes null. So this way you have to apply the properties which we have seen and try to solve the problem. So some questions based on principle of inclusion and exclusion. So all guests at dinner party drink coffee or tea. 13 drink coffee. So n of C equal to 13 and n of T equal to 10. 4 drink both. So n of A intersection B is nothing but 4. So let it be B and A. So they are asking, what is the question here? How many are there in the group? Total people in the group. So it is nothing but n of A union B equal to n of A plus n of B minus n of A intersection B. So 13 plus 10 minus 4, so 19. 23 minus 4, 19. Right. This is the solution. Another question, let's see. Quality control in factory pulls 40 parts with paint, packaging and electronic. So there are 40 total. So n of A union B union C is given. Out of 28 are having paint defect. So 28 plus 17 have packing defect. 17 plus 13 have electronic defect. 13. Next, 6 have both paint and packaging. Minus 6. 7 have both packaging and electronic. Minus 7. 10 have both paint and electronic. So minus 10. Now, did any part have all three types of defect? So what is missing here? N of A intersection B intersection C is missing. That is our variable x, which you have to find out. So if you solve this, if you can find out the x value here. So 28, 30, 45, 45 plus 13, 58, 58 minus 10, 48 minus 6, 42, 35. So this value is 5. X value is 5. Did any part have all three type of defects? Yes. How many? 5. How many? It means X value is 5. Based on principle of inclusion, exclusion. Let's see two more problems. How many positive integers not exceeding 500 are divisible by 7 or 11? So here is asking how many integers are there which are less than 500, which are divisible by both 7 or 11. So first find out numbers which are divisible by 7. So it is nothing but 500 by 7. So if you keep calculating it, 500 by 7, I think value is somewhere. So it is around 71.42. So we have to take the lower value, that is 71. Similarly, n of b is nothing but 500 divided by 11. How many elements are there which are only divisible by 7 is 71. Which are only divisible by 11, we have to find out. So it is 500 divided by 11. So it is 45.45. We will take the floor value, that is 45. Now, how many elements are divisible by both 7 and 11? N of A intersection B. So it is about 500 by 7 into 11. That is 77. You have to divide it. So you get around something 6.49. So we take it as 6. So you have n of A, n of B and n of A intersection B. How many are not exceeding 500 are divisible by 7 and 11. So we have to find out n of A union B. So that is nothing but 71 plus 45 minus 6 will give the solution. So it is 110. There exist 110 elements which are divisible by 7 or 11. Okay, this is how we solve it. Similarly, determine the number of integers between 1 to 250 that are not divisible by, see, that are not divisible by 235. Okay, so first you find out a number of elements divisible by 250. So n of A will be 250 by 2, that is 125. N of B will be 250 by 3. So it is somewhere around 83. Then n of C equal to 250 by 5, it is 50. Now both n of A union B, so 250 by 6. So if you divide, so it is 41.66, so we took 41. N of B union C, no, intersection, sorry, we have to find out intersection. This is intersection actually. B intersection C, so common, that is 250 by B and C means 3 by 15. You have to find out how many elements are there divided by 15. So it is around 16. Similarly, n of C intersection A. So 250 divided by 10, this is very simple, 25. Now we are having 250 total elements. So n of A, n of B, n of C is there, intersection is there, and we don't have the common. We have to find out how many are not divisible by. So we have to find out how many are divisible by. For that, n of A intersection B intersection C is nothing but 250 divided by 2 into 3 into 5, that is 30. So if you make 250, so this is around 8. So apply your formula. We know that number of elements, so that is 125 plus 83 plus 50 minus 41 minus 16 minus 25 plus 8. This will give you total elements. And you have to find out which are not divisible by 235. So this is divisible by 235. Not divisible by 235 means you have to find out complement of A union B union C. Complement you have to find out. Okay. So if you can solve this, you get the solution. Yes. So let's stop here. We have seen set properties and set operations, and also the very important principle of inclusion and exclusion. So in the next session, we will be studying about the fuzzy set and few problems on functions and relations. Thank you.